Okay guys, I'm Chelsea and today we're going to be working out a chemistry problem. In this example, we're going to be calculating the freezing point of a solution containing 12 grams of naphthalene and 125 milliliters of benzene. Pure benzene has a density of 0.877 grams per centimeters cubed and melts at 5.5 degrees Celsius. The freezing point depression constant for benzene is 5.12 Celsius per molality. Okay, so now let's work this out. The question says we're going to be calculating the freezing point of a solution. That should give away that we need the formula. The change in freezing point is equal to I Kf Cm. Cm is for molality. Kf is the freezing point depression constant. And I is for the number of ions. This is for the change in temp. Now, next step, we need to write down all the information that is given to us. So we have 12 grams of naphthalene, and that is in 125 milliliters of benzene. What else is given? We are told that benzene melts at 5.5 degrees Celsius. The density of benzene is equal to 0.877 grams per centimeters cubed. And the freezing point depression constant, which is the Kf for benzene, is equal to 5.12 Celsius per molality. So now, in this problem, we're given the Kf right here, and we are not given the molality, but we are giving enough information to be able to solve for the molality. Now, what is our I? Our I is equal to our number of ions. In this case, we're dealing with benzene, which is a molecular compound, meaning there's nonmetals and nonmetals. In that case, our I is equal to 1. If our I was an ionic compound, meaning metal and a nonmetal, our I would increase. So our first step in this problem is to solve for our molality. Molality is equal to your mole of solute over your kilograms of solvent. What is our solute? Our solute is our naphthalene because they said it's in 125 milliliters of benzene. Therefore, we know we have 12 grams of naphthalene, but we don't want grams, we want moles of our solute. How do we calculate the moles of our solute? We need to use our molar mass of our solute, which is our naphthalene. We need to calculate the molar mass of naphthalene. We have 10 carbons, which according to the periodic table is equal to 12 grams. We have 8 hydrogens, and on the periodic table, it's equal to approximately 1 gram. So our molar mass of our naphthalene is equal to approximately 128 grams. We're going to use this conversion factor in order to calculate our moles of our solute. We always start with what's given. We're given 12 grams of naphthalene, and we want moles. Okay, so the moles are going to go on top and the grams are going to go on the bottom. So 1 mole of naphthalene is equal to 128 grams of naphthalene. You do 12 times 1 divided by 128, and that will give our moles, which is equal to 0.0938 moles of our naphthalene. Now, why is it 3 significant figures? Because according to our calculations, we have 3 significant figures in our 12 grams. So our answer will have 3 significant figures. So now we have our moles of our solute. So we have half the piece of the puzzle to solve for our molality. What else do we need? We need our kilogram of our solvent. Yes, they gave us our solvent, which is benzene, but they gave it to us in volume. Anytime they give you a volume, you can use the density to convert that into a mass. So now we're going to use our density of benzene and our volume of benzene in order to get the mass of benzene. But now remember, we don't just want grams, we want kilograms of solvent. So we're going to have to do one more step at the end and convert our grams to kilograms. Now over here, our density says 0.877 grams per centimeters cubed. Now remember, 1 centimeters cubed is equal to 1 milliliter. Therefore, you could write the density over and say 0.877 grams per milliliter. And now that is going to be our conversion factor to convert the volume. So we have 125 milliliters of benzene, and we can use our density to convert to grams. If we want grams, grams is going to go on top, and we want to get rid of milliliters, so that's going to go on the bottom. And our conversion factor is this. There are 0.877 grams per 1 milliliter of benzene. So if we take 125 times 0.877 divided by 1, that'll give us our grams. But we don't want grams, we want kilograms because that is in our molality formula. So therefore we have to take it one more step. We want kilograms, so kilograms is going to be on top. We want to get rid of grams, so grams is going to be on the bottom. Now, remember, grams is a smaller unit than kilograms, so there are 1,000 grams in 1 kilogram. So now our grams cancel out with our grams, and we'll be left with kilograms. So if you just go ahead and divide that number that you got before by 1,000, that'll give you your kilograms, which is equal to 0.110 kilograms of benzene. Okay, so now we have all the pieces of the puzzle in order to calculate our molality. We have our kilograms of our solvent, and we have moles of our solute. So now we know that molality is equal to moles of solute over kilograms of solvent. We're going to go ahead and plug that formula in. So our moles of our solute is the 0.0938 moles, and our kilograms of our solvent is the 0.110 kilograms. You do this division of 0.0938 divided by 0.110, and you end up with a molality of 0.853 molality. Okay, so now that we have this as our molality here, we have all the information we need in order to find the change in temp. We have our molality, which is our CM. We have our KF, which they told us. We know our I is equal to 1 because it's a molecular compound. So we plug all this information in. So our change in temp is equal to our I, which is 1, times our KF, which is 5.12 Celsius per molality. And we have our molality, which is 0.853 molality. You do this multiplication, 1 times 5.12 times 0.853. Our molality will cancel out, and we'll be left with our change in temperature is equal to 4.37 Celsius. Okay, so now we just solved for delta T, but now that's not the final answer. The question says calculate the freezing point. What we solved for was the change in temperature, and that's why they gave us this information right here, that benzene melts at 5.5 degrees Celsius. We need to use the melting point and the change in temperature in order to calculate the freezing point of the solution. Therefore, we take the melting point, which is 5.5 degrees Celsius, subtract our change in temp, which is 4.37 degrees Celsius, and we come up with our new freezing point of the solution, which is equal to 1.1 degrees Celsius. The reason it's 1.1 degrees Celsius is because due to significant figures, when you do subtraction, you use the least amount of places past the decimal. This one has 1 place past the decimal, this has 2, so the least is 1 place. So our answer, our final answer is 1.1 degrees Celsius. Okay, so now that we have our final answer, let's do a quick recap because I know it was a lot going on. So the question stated that we needed to calculate the freezing point of a solution containing 12 grams of naphthalene and 125 milliliters of benzene. They gave us the density, the melting point, and the freezing point depression constant for benzene. Therefore, we knew that we needed to use this formula. We have change of temp is equal to I, which are our ions, our freezing point, depression constant, and our molality. What was given was our mass of our solute, our volume of our solvent, the melting point of the solvent, the density, and the Kf. Therefore, we knew that we needed to calculate the molality before we could plug anything into this equation because they gave us our Kf, which was 5.12, and we knew our I was 1 because it was a molecular compound, but the only thing that wasn't given directly was our molality. Therefore, we needed to know that molality was equal to moles of solute over kilograms of solvent. Therefore, we needed to take our solute and convert that to moles. And that is what we did here. We took our mass of our solute, we used our conversion factor of 1 mole over 128 grams of our solute, and we got moles of our solute. But that wasn't it in order to determine molality. We needed to take our benzene and convert that into kilograms because that is what was needed for the formula. So we took our volume of benzene, we used our density as our conversion factor, then we converted that to kilograms in order to get our kilograms of our solvent. Now that we had all of our information to solve for molality, we had our kilograms of solvent and our moles of solute, we plugged it into the molality formula to solve for our molality. So then we had everything we needed in order to determine the change of temp. We had molality, we had our I, and we had our Kf. We simply plugged in all our information here in our formula and solved for our change in temp. Now after we got our change in temp, remember, that's not the answer. There's a reason they gave us this information over here. They told us that benzene melted at 5.5 degrees Celsius, and what they wanted was the freezing point, and this is just the change in temp. So therefore, we took the 5.5 degrees Celsius, which is the melting point, and subtracted it from our change, and got our new freezing point of our solution, which was 1.1 degrees Celsius. So there we go. That was this example.